Well, the question reads, two towns A and B are connected by a regular bus service with a bus leaving in either direction every t-minute. So time is given, it says t-minute, it's given in minute. A man cycling with a speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion. So this is in the direction of his motion, and every 6 minutes in the opposite direction. What is the period T of the bus service, and with what speed do the buses ply on the road? So the question is pretty simple. There are two towns A and B which are connected by a regular bus service, and bus from either of the town leaves every t-minute. This is given in minute. You should make a note of it. There is a cyclist who is moving with a speed of 20 km per hour. So here it is given in kilometer per hour. So you should make a note that you will convert this t-minute into hour as well. And what does the cyclist notice? He notices that there is a bus moving in his direction every 18 minutes, which has to be again converted into hour. Also, he notices that there is a bus plying in a direction opposite to his direction of motion every 16 minutes, which also again needs to be converted into hour. So what is that we are supposed to calculate? We have to calculate the time at which every bus actually leaves the town, and we need to calculate the speed of each bus if we assume it to be uniform. So the acceleration is 0. So it's a uniform motion. So what is the first thing that should come to your mind when you read this problem? You should make a note that all the frames of reference here are in motion. For example, the cyclist is in a moving frame, which is a cycle. The buses are also in motion. So this is a numerical based on relative velocity, because all the three frames of reference are in relative motion to each other. And when the cyclist spots the buses in either of the direction, both the buses are in motion and the cyclist is also in motion. So you will have to take into account the relative motion of the buses with respect to the cyclist when you want to solve the problem. So let's see how do we go about this. Let's first picturize what is given. So solution. So let's say this is town A, okay, and this is town B. They're connected by a regular bus service. Let me say this is the bus stop for town A, and this is the bus stop for town B. So the bus leaves town A, also leaves town B every t-minute, right? So what do you mean by every t-minute? If I convert this into hour, 1 minute is 1 by 60 hours, so it is t into 1 by 60 hour. So it leaves t into 1 by 60 hours. So this is when the bus leaves, right? This is the information given. But the numerical also tells us that there is a cyclist, right, who is riding his bike or a cycle, and with a speed of how much? He is moving at a speed of 20 km per hour from A to B. He spots buses, one moving in his direction. So this bus moves in his direction at a speed of every 18 minutes he spots a bus moving past him in his direction. Also he spots buses plying in the opposite direction every 6 minutes. Right? Here also you can convert them into hour by simply multiplying it by 1 by 60. So that gets converted to hour. Even here 6 into 1/60 hour, right? So this simplifies most of the problem, and with this you can easily solve. Now let us assume that the velocity of the buses, BVB, velocity of the bus, let us assume it to be BV. Okay, similarly velocity or the speed rather of the cyclist, let us call it or represent it by VC. Okay, now but what is the velocity of the buses that are moving in the direction of the cyclist? So that is relative velocity, because the bus is also moving and cyclist is also moving. So therefore velocity of buses moving in the cyclist direction can be represented by VBC, that is the velocity of buses with respect to cyclist, and by definition, relative velocity definition, it is VB minus VC, right? So it is as simple as that. Now these buses moving with VB minus VC velocity cross the cyclist every 18 minutes. So they cross him every 18 minutes or 18/60 hour. So they cross him every 18/60 hour, right? So we know the velocity of the buses moving in his direction. We also know the time that he spots, or the time that each bus moving in his direction crosses is given by 18/60. So since you know the velocity and since you know the time, you can easily calculate the distance covered by these buses which are moving in the cyclist direction. So now I will write down an expression for the distance traveled by the buses moving in the cyclist direction, which will be simply VB minus VC into 18/60, that is the velocity of the buses moving in the direction of the cyclist, into the time that each bus is spotted when it is moving in the direction of the cyclist. So it's very simple. So let's write that down. So we get an equation. Therefore distance covered by the buses in the direction of the cyclist should be equal to velocity of the buses in the direction of the cyclist into the time that it takes. So what is VB? By definition, it is VB minus VC. And what is the time it is taking to cross the cyclist? It is simply 18 divided by 60, right? So this is the actual distance. So this is the kilometer covered actually. Now also there is some extra information given in the numerical. Also we know that each bus leaves the town every t minute, right? Or every t/60 hour, right? So since we know that each bus leaves the town by in a time t by 60 hour, and the velocity of each bus we have assumed it to be vb. Therefore distance, we can also write this as distance covered by both buses should also be equal to velocity of the buses into the time it takes, that is time it leaves each station, town B and town A. And what is t? T is vb into t is t by 60, right? So you can equate these two distances, so you end up with an equation. Therefore this will be vb minus vc into 18 by 60 should be equal to vb into t by 60. So you can cancel 60 on either side, and you end up with simply vb minus vc into 18 is equal to vb into t. Let us call this as equation 1, right? Now similarly we can even write an equation for buses moving in the opposite direction. So let us first write down velocity of buses moving in the opposite direction will be equal to again VBC. So that is by definition VB minus of, now we know that these buses are moving in a direction opposite to the direction of the cyclist. So therefore, since they are moving in a direction opposite to the direction of the buses, the velocity of the cyclist will now be written as negative. So this becomes VB minus of minus VC, letting us know that bus and the cyclist are moving in an opposite direction now. So this will be VB plus VC. Now what is the time that the bus takes to cross the cyclist in the opposite direction? So time taken to cross the cyclist in opposite direction will be how much? 6 minutes, right? So 6 minutes can be written as t is equal to 6 by 60 hour. So therefore you know the velocity of the buses moving in the opposite direction and the time it takes. You can even calculate the distance traveled by the buses moving in the opposite direction as the cyclist. So therefore distance covered by buses moving in cyclists opposite direction will be simply again VBC into the time that it takes, that is t. But what is VBC? Here in this case it is VB plus VC, and what is the time it takes? 6 by 60. So this will be into 6 by 60 hour. But these buses, as we know in general, they also cover a distance which is equal to VB into T, that is VB into T by 60. Therefore, we also know the distance covered by these buses is, but distance covered is also equal to how much? Velocity of the buses into capital T, that is the time it takes to leave each town. So this is in minute, we convert that into hours, so it becomes VB is equal to T by 60. Now let's equate the distances of the buses that are moving in the opposite direction. So that will be now VB plus VC into 6 by 60 is equal to VB into T by 60. So you cancel 60 on either side and you're left with VB plus VC into 6 is equal to VB into T. Let us call this as equation 2. So now you have two different equations. This is your equation number 1 and this is equation number 2. So now you can eliminate the unknowns and find out some terms by dividing equation 1 by equation 2. So now let's divide equation 1 by equation 2. Dividing equation 1 by 2, we get, what was equation 1? Equation 1 was VB minus VC into 18 is equal to VB into T, right? So you divide the right hand side by right hand side and left hand side by left hand side. So equation 2 was VB plus VC into 6 is equal to VB into T. So VBT gets cancelled and then you have 6 1 times, 6 3 times. So what you do, you just cross multiply. Now first let us multiply it with 3. So this becomes 3VB minus 3VC whole divided by VB plus VC is equal to, so this 1 times, this 1 times, you have 1 here. This simply implies this, if you multiply on this on the right hand side, you get 3VB minus 3VC is equal to VB plus VC. So therefore 3VB, I bring this VB on the left hand side, that becomes minus VB. I bring this on the right hand side, so minus becomes plus. 3VC plus VC. So this will be 2VB will be equal to 4 times the velocity of the cyclist. So 2 1 times and 2 2 times. So velocity of the buses is twice the velocity of the cyclist. Now is the velocity of the cyclist given in the numerical? Yes. We know that the velocity of the cyclist is 20 km per hour. So you just multiply this by 20 and you know that the velocity of the buses is 40 kilometers per hour. So we have already found out the velocity with which the buses are moving. Now using any of these equations, you can even find out the time that each bus is plying with. So let me just take this equation. So from equation 1, what is equation 1? Equation 1 is VB minus VC into 18 by 60 is equal to VB into T by 60. So you have 60, 60 getting cancelled. Now we'll substitute the values. We know VB is how much? 40 minus velocity of the cyclist is 20 into 18 is equal to velocity of the buses is 40 into T. And therefore 20 minus 40 minus 20 is 20. 20 into 18 is equal to 40 into T, right? So 18 2 times is 36. You have a 0. So 360 is equal to 40 T. Therefore, this can be written as T is equal to 360 divided by 40. So for 9 times. So you easily get, we know T is given in minutes. So what is the time each bus takes to leave? Leaves from, it is leaving every 9 minutes from town A and town B. So therefore T will be simply equal to 9 minutes. That's how you do this.